Hey guys, I'm here recording some lessons for you so that we can send them to you and we can continue to learn about geometry, which I know you're looking forward to. I hope you're all doing okay and staying home and being healthy, thinking about all of you guys. Mila's here with me, handing me lots of books. And I'm just going to go over a few things, and I'm also going to be sending you some fun kind of creative assignments that I thought we could do together. But thank you. So here we go. As you guys remember, we had started talking about surface area last time when we were together, and we also touched on volume a little bit. So I'm going to continue talking about that with you guys today. We are going to go over a few other shapes. We started talking about rectangular solids or rectangular prisms, as we also can call them. Something like a 3D shape, you know, like a box of some kind, right? Today we're also going to talk about a cube, how that's a little bit different. All right, so we're back. We had talked last class about basically length, width, and height. And that was the formula we were using for rectangular solids to find the volume. You might have just always remembered from when you were a kid, length times width times height, right? Length times width times height. That is of a three-dimensional rectangular solid. And last class, we derived the formula for surface area. We talked about how finding surface area of a 3D object has to do with taking literally just the area of this side and the area of the matching side and adding that together with all the areas of the other outside surfaces, surface area. So this surface would be like side and then this other side that you can't see right now. We have front side and back side, and then we have top and bottom. And so we wrote down the formula of surface area based on that. When we talked about it together in class, we had area of the front plus area of the back plus area of the left plus area of the right plus the area of the top plus the area of the bottom. And whenever we condense that, we have to think about how we're saying, like, we're adding the front and the back, which are the same shape with the same area. So we're just adding those twice. So we can say like 2 times that surface. So for example, 2 times length times width. And we add that together to the other side. So we would have 2 times width times height. And 2 times, which one are we missing? We have length and width. We have width and height. We don't have length and height. So length and height. That just means that we want to make sure we're covering each surface here. So then when we do multiply each surface by 2, we add them all together, and that is the surface area of a rectangular solid. And that's what we did at the end of last class. So I believe that you guys were working on one. Let's do that same one, and then we'll talk about how does this differ at all when you look at it for the surface area of a cube. Like when you play with dice, for example, you look at all those 6 sides, and we're going to look at shapes like that and how we can kind of make an even more simple formula for those. Hi Mila, you can't have this marker.
Oh, exactly.
Okay, so we have, all right, so here we have this rectangular solid or rectangular prism, and we want to find the surface area. We are going to take these dimensions that we have here and plug them into our formula. You can also, if you forget about this or you can't find it on your formula sheet, which you are allowed to have when we take the quiz, then you can also try to just remember how to do it, and you will still get the right answer. Yes, wonderful, Mila. I have such a great helper today. Yeah, so to do my formula, I'm going to say 2 times the 3 times 4 plus 2 times, let's say this time we're going to do 4 times 10. We can do these in any order, remember, as long as you make sure you're doing each combination. So then we are also going to do 3 times 10. Okay, then we simplify all of it. So we have here 12, so that's 24, plus 40 times 2 is 80, plus 30 times 2 is 60. Do you guys see what I'm doing? I'm just simplifying inside here and doubling it or multiplying it by the 2 on the outside. If you wanted to, you could always do one more step and then multiply by 2, because you would have 12, 40, and 30 there. Okay, so then we're just going to add together 24 plus 80 plus 60. Remember that in this unit you're allowed to use a calculator, but a lot of times we don't need one for these problems. So let's see, that would be 104, 164, I'm thinking. And it would be centimeters squared, because even though we're doing a 3D object, it's still a type of area. So we're figuring out the surface area. So we're still going to write centimeters squared. Mila, can you draw on those papers? Do you want me to hold you? Okay, so we have to make sure that we're putting the units as units squared, in this case centimeters squared, because it's still, even though we're using a 3D object, it's still only of a two-dimensional surface, because we're just wrapping that surface around the outside of the shape. So it's still a measurement of area. We're going to use units squared, in this case centimeters squared. Let's check the volume of this same shape here. So length times width times height would have us putting 4 times 3 times 10, okay? So 4 times 3 is 12, times 10 is 120. So we get 120 centimeters, and now we're not using squared. We're going to use cubed. That's right! Mila's playing with some 3D objects. Can I show them, Mila? Next, we can learn how to find the volume and surface area of a sphere. No? All right, we'll put it up here. Okay, so 120 centimeters. I'm not finished here. I have to make sure that I label it cubed, because we're doing the volume. We're literally talking about how many cubic centimeters could fit inside this shape. So that is what we kind of talked about last time, a little bit of review there. Now, what if we had a cube? What if this was actually the same on all sides? Let's look at that. The formula can be the same, but you can also use a little bit easier version of this. Okay, so let's say you have a cube. Let's use, maybe we have a 2-inch cube. I'm doing my best here to draw a shape for you. So let's say it's 2 by 2 inches by 2 inches by 2 inches. If we want to use that with our formula of length times width times height, that's perfect. We can do that. 2 times 2 times 2. And we know that that would become 8 inches cubed, right? And we can think of an easier formula when we're using cubes if we want to. So the volume of specifically a cube, you can say side times side times side, right? Because they're all actually the same value, the same side lengths. Wow, what is that? Thank you. So since they are all the same side length, then we are going to multiply them together. They're all the same. So another way you could write this is volume of a cube is side cubed. Does that make sense? So let's look at that. If you put in 2 cubed, you get 8 inches cubed, just like we got before. Does that make sense? By the way, if any of you guys have questions, you absolutely should feel free to message me on WhatsApp or send me an email, and I can answer questions individually. Okay, so let's say we were going to look at the same shape here, but we want the surface area. Again, we can do our same formula of surface area. This case now we're doing, we can say 2 times the length times the width plus 2 times the length times the height plus 2 times the height times the width. Remember, sometimes I might write those in different orders, but as long as I make sure I put each one, then we're totally fine. But as you guys noticed before, we decided to just call each of the sides of the cube side, or S. Okay, so this is side, side, and side. So if you want, because they're all the same, you can just put in those in this formula and get a more simplified version for surface area of a cube specifically. So let's say we have 2 times side plus 2 times side plus 2 times side. Does that make sense? Mila, does that make sense? So we can simplify that to be 2 times side squared plus 2 times side squared plus 2 times side squared. Because s times s is s squared. Now, interestingly, we can do this version of combining like terms. We have 2s squared plus 2s squared plus 2s squared. We have 2, 4, 6 s's squared going on here. So we can actually combine all of this into 6s squared. 6 times the side squared. And if you also think about it, surface area, we have the area of this one box here, this square, is side squared. Does that make sense? So this area specifically is this side times this side. So side squared. Okay, how many of these do we have on, let's say, a cube or like a die, like from dice in a game that you're playing with? You have 6 exactly the same of this. So that also makes sense to say that the whole surface area of this whole cube is going to be 6 times one of those sides. So that's another way to look at this formula. So the surface area of a cube, you can use 6 times side squared. Okay? Okay, guys, so as you will see in our special project that we're going to be doing this week, I'm going to have you guys find some objects in your home and explore these measurements on those real life objects. Water. So basically, I want you to find a rectangular solid, maybe a cereal box or some other kind of box in your house, or maybe a thick book, or whatever you decide. It could be large or small, and hopefully some type of measuring device, some way to measure it. You might have rulers at your house. If not, maybe a tape measure, either a soft one for sewing or a construction like type of tape measure you would use with building. Or some of you have apps on your phones that can measure pretty well. So that's all those are all some of the options that you can use for the project we're going to be doing this week. I think that you guys, I'll go over the instructions for you again, but you probably feel pretty confident finding the surface area and volume of rectangular solids by now. And the other thing I'm going to have you do later in the week is to find a cylindrical object, or a cylinder. I don't know if you guys remember, but a cylinder is kind of like a can. Today, the best cylinder I have in this room with me is this Hydro Flask, but if I wanted to make it a cylinder, I would need to cut it off about here, okay? So a cylinder, a circular base, actually 2 bases. So it has like a bottom and a top that are circles. And then in between, there's just this kind of circular flat surface that's wrapped around. Okay, if you thought about the surface area of something like this, you could actually, let's say you had a softer material and I wanted to cut here and cut out around the bottom and then cut straight up one side and then cut around the top, what would I be left with? This is for surface area. I would actually end up having, let's say you had a can and you cut it, okay? Let's say I cut, and I unwrapped it. You actually end up with a rectangle and 2 circles. That would be for the surface area of a cylinder. Think about it and send me a message if this doesn't make sense to you guys. But these 2 circles, it would be like the top and the bottom, and then this wrapped around the outside. That's how we are going to ultimately find the surface area. And also, we're going to find the volume. The volume is very interesting. It has to do with finding the area of the base. So we have like the circle, and we can do this with lots of different shapes we'll see. So let's say you had a circular base. So to find the volume of a cylinder, you actually take the base, you actually do the area of the base, and then you're going to multiply it by the height. And it's basically like taking that circle and being like all the way up, and like one word for it is extruding, or you know when you're a kid and you have Play-Doh and you kind of squeeze it through a circle, you kind of puts this tube out slowly, right? Imagine how you have lots and lots of the little bases just multiplying over and over again, times however long you make it, however long the height is. Thank you, Mila. Oh, okay. You're gonna help me erase?
Yes.
Okay. Okay, so let's look at the formula for cylinders. And then I'm going to actually have you guys also, for Wednesday, look for a cylinder in your house that you can use to find these, find the answers for the surface area and volume of a cylinder. So first, let's draw a better cylinder than this. Okay, so if we draw a really nice cylinder, you'll notice that it has a circular base and a circular top, and those are the same. Those two parts are equal in size for a cylinder. And you can take the middle point or the center point of the top circle and the center point of the bottom circle, and if you connect them vertically with a straight line down the center of the shape, then you get the height. You can also actually get the height by measuring the height of the side, which is what you'll be doing later on. For example, if you find your shape and you measure from here to here, you can get the height as well. Okay, so H here, we can say that the height, you can call it the distance between the two bases, which is like the distance between the top and bottom. Okay. We also have two parallel circles. So cylinder. How do you spell cylinder? Yes. Two parallel circles, right? Of the same size on the top and bottom. Okay, so we have these two parallel circles of the same size, and there's one on the top and one on the bottom. I feel like you guys understand that. So what we're going to do, if you think about it, the way, like I was just talking about extruding the shape, before, when we did length times width times height on a, let's say we had a prism, right? Like a rectangular prism, like that. Okay, think about how we can say height times length times width, something like that. The same thing was happening here whenever we did length times width times height. We got those 3 dimensions. We got the base. We took the area of this base and then we extruded or we multiplied it by the height. So it's like we're going and filling up that whole space with the shape of the base, like. And that's really the way that you can think about a lot of these volume formulas. So the volume of a rectangular solid, you guys know, is length times width times height. If you think about it like this, it's the same thing with our cylinder. We're going to take the area of the base and we're going to multiply it times the height so that we can get the whole shape and the whole inside of it. So we can talk about how volume is like the area of the base. Sometimes they call that a capital B times the height. So sometimes you see volume is big B, which is different than the trapezoids and the big B, that's different. But the area of the base times the height, okay? So with this guy, it was like length times width times height, if you can think about it like that. Well, what if we do the volume of a cylinder? We're gonna have volume of a cylinder is, we don't do length times width for the base though. How do we find the area of a circle? Pi r squared, right? You guys remember? So basically you're gonna have pi r squared, okay, just like we've been doing with circles before and everything, times the height. So it's like pi r squared times height. Not so hard, right? It's actually pretty straightforward. So this is what our formula will look like, or just pi r squared h, pi r squared times height. let's do an example. Remember that the R you can find here, the radius of the circle. Let's say we have a height of 5 and a radius of 3, let's just call it centimeters, okay, of this type of can or cylinder that we have here. So what we want to do is take the, first find the area of the circle. So we're going to have pi times 3 squared times 5. So we end up with pi times 9 times 5, right? So let's just quickly do that. What's 9 times 5 is 45. So I'm going to work it out just up here.
3.14, let's do this.
All right, I'm getting 141.3 centimeters cubed. Yes, because this is volume, right? So centimeters cubed. We can double check that. I'll check my math later and just come back in if I made any errors, but that looks right. Okay, so if you wanted to find the surface area, remember how we talked about if you cut it apart, right? You cut the side and you unwrap it and you cut off the two circles, then you just need this area outside the cylinder. Nothing inside, no volume here. This was the volume, okay? To do the surface area of a cylinder, we just do those separate parts. So how can you figure out this piece? I wish you guys were with me in person to help me answer that, because I think you would figure it out. So remember how if you cut this right here and you undid it and you know unwrap the piece from around the circle, you would have a straight line. It's kind of what we have here. So we need to figure out we know that this is going to be the height of it. So like for example, if we're using this one, this is 5, right? Because we just took it and unwrapped it. So it's still 5 high, 5 centimeters. And how do we figure out the top, the length of this shape, right? We have the height and we want the length. Do you guys remember what we want to calculate if we want to do the length, the linear distance around this, which is the same as this? We would use the circumference, right? Because it's like the circumference of the circle got disconnected, and unfolded into one straight line. So this is going to be 2 pi r. Does that make sense? Because this is the circumference stretched out times the height, right? So that's this area of this part. And then we just need 2 times the area. So we have pi r squared and pi r squared here. So all that together is going to be the surface area. So we can write it down a little more concisely maybe. So basically it's like the surface area is the area of the top circle plus the area of the bottom circle, right? Plus the area of what we're going to call this rectangle. Okay, so in order to do that, that is pi r squared plus pi r squared for those two circles and their area, plus 2 pi r times the height, right? 2 pi r times the height. So that turns into 2 pi r squared plus 2 pi r times the height. So that is the surface area of a cylinder. Cool? So, guys, let's calculate the surface area for this specific one here. Okay, so we're going to take this simplified formula here. So 2 times pi times the radius squared. The radius is still 3, so times 3 squared plus 2 times pi times 3 times 5 for the height. Okay? So let's simplify that out. I have it written out here when I did it. So, and at home you probably can work on this on your own and see if you get the same answer that I'm getting. So here we have surface area is 2 pi times 9 plus 2 pi times 15. Does that make sense? Here's the 15, here's the 9, because this is r squared and this is r times h. So this is like similar but different pieces of this formula. All right, so we end up getting here 56.52 plus 94.2. So we get about 150.72 centimeters. Remember that it's squared because it is surface area. So this is the surface area of this cylinder is this. Okay? Thanks. All right, guys, I'm going to assign you some reading and practice problems from your textbook to go over a few more examples of problems like those that we just did. I want you to practice the volume and surface area of a rectangular solid, the volume and surface area of a cylinder, and then we're going to work on our little project this week of trying this out on a couple real objects from your house. Please let me know if you have any questions and feel free to message me on WhatsApp or email me, and I am absolutely available to help you out. I'm happy to talk to you guys one-on-one if you want any guidance going through these problems. Okay, thank you.